Hello dear students, how are you? I wish all of you will be healthy and safe. So student, in this video, I am going to discuss an important thing, that is searching. Okay, what is searching? To find the position of an element in a list or tuple is known as searching. Okay, so there are two methods to search an element. There are two techniques to search an element, that is linear search and binary search. Okay, so you have understood what is searching. The searching is simple. The finding the position of element in the list is known as searching. Okay, for example, suppose you have a list. This is the list of element. If you want to find out the position of 78, the position of 78 is 3. So this is called searching. Okay, so first I will tell you what is linear search. Linear search means the searching line by line, means one by one. So linear search or sequential search, it is called sequential search because you have to search an element sequentially. It's a method for finding an element within a list. It's sequentially. What do you mean by sequentially? Means one by one. Checks each element of the list until a match is found or the whole list has been searched. So it checks sequentially until the a match is found. Okay. So in this technique, searched element is compared with each element of the list. Okay. So you have to compare, you have to check your searched element one by one to the each element of the list. Okay. If element is found, so index is displayed. Okay, so what is the algorithm for linear search? First of all, start from the leftmost element of the given list and one by one compare element X, this is your searching element, with each element of the list. Okay, if X searched element is matched with the element of the list, it returns the index value. It means your element is found. If X doesn't match with any of the element, if your searched element is not matched in the list of any element, then it will return -1. It means your element is not in the list. Okay, let's take an example. Okay, so here you have the list of elements like this. Okay, and this is your searching element. Okay, for example, you are searching 78. So 78 first, 78 will be compared with 89. So 78 is equal to 89. No, so now it again it will search the element to 96. It is equal to 96. No, then it will be compared to 55. It is equal to 55. No, if you want to search 78 is equal to 78, so in this case your index will be 3 and position will be 3 plus 1. So your position of the element in the list will be 4. Okay, for example, if you want to search the element 100, okay, if your searching element is 100, so in this case one by one you will compare your searched element to each element of the list one by one. So 100 is equal to 89, no. 96, no. 55, no. 78, no. 74, no. 42, no. 63, no. It means your list is not, sorry, your item is not in list. So in this case it will return -1. If your index is -1, so it means it will indicate that your element is not in the list. So this is the algorithm to find out the element, to find the position of an element using linear search. Okay, let's see its its program. Okay, for example, uh, so we are creating a function to find out to linear search. Okay, so here I am increasing the size. Yeah. The function name is linear search. Linear search. So right on, this is should be in small letter. So linear search. So what will be the parameter? The parameter will be your list. First of all, you will pass the list and you will pass the element which you want to search. Okay, so these two parameters will be passed to create this function linear search. Okay, so what you will do, first of all you will count how many elements are in the list. So for this you will use the len function. Okay, so len and your length of your list. Okay, now how can we access, how can we reach to the each element? We will use the for loop. Okay, so write down the for I. Okay, for I in range. For what? I in range, or you can search I in underscore list. But using list you cannot determine the position, so in this case you have to use a range function. Okay, for I in range I. Okay, so you have to compare your element. So write down, check if your x is equals to, if your element is equals to what? Underscore list, and here you will write down the index number. Your index number will be I. What does it mean? It means your element is equal to the element of zeroth index. So what does it mean? Your element is equal to the element of zeroth index. So in the zeroth index you have 89 here. So it is your searching element is compared to the first index number. Okay. So if element, your searching element is equal to the element, so in this case it will return what? It will return I plus 1. Why I plus 1? Now here you can see the index number plus 1. Okay, this is your position. If your index number is 3, so in this case your position will be 1, 2, 3, 4. That's why I am increasing it by 1. Okay, so now return plus 1. Okay. If this function doesn't return any value, so in this case it will return minus 1. Okay, if your element, your searching element is in the list, so in this case it will return I plus 1. If your element is not in the list, after completing this for loop, so in this case it will return, it will not return any value. Okay, so if it not return any value after completing for loops, it will return minus 1. If it return minus 1, it means the element is not present in the list. Okay, now this is your calling of function. So now here I am writing here, it's the, sorry, definition of function. This is your definition of function. Now here I am calling the function. Okay, calling of function. So here you can take the list. Suppose your list name is my list. Okay, so in list you have multiple items like this. Like this. Okay, so this is your list and you have to search the element. Okay, so here you will take the position. Okay, position will be equals to, so you have to call the functions. So write down here linear search, and you have to pass the list. So here you have to pass the two parameter to call this function. The first parameter will be of list type and second parameter will be your integer, that is the searching element. Okay, so here you will, your list name is my list and you're searching, suppose you want to search the position of 85. So here write down the 85 here. Okay, so print the position, or first of all you have to check if POS, if position is not equals to minus 1, it means the searching element is present in the list. If your position is not equal to minus 1, or you can write here if position equals to minus 1. What does it mean? It means your item is not present in the list. If position equals to minus 1, then write down the print statement, element is not in the list. Okay, if position, the value of position is not minus 1, it means the element is present. So in this case, if minus 1 is returned, it means element is not in the list. If it return I plus 1, it means any positive values. In this case, your element is present in the list. So here write down else print element is found, element is found at POS, position. Okay, the program is complete. Now check it. If the position is -1, it means element is not in the list. If your position is not -1, any positive value, so in this case it will return your element is found at dash position. Okay, now run this program. Okay, one thing is missing. If x equals to list I. So what is the problem for increment? So what is the problem? Okay, same column is missing here. Okay, now run your program again. Now you can see your element is found at fifth position. Now you can check 85, 1, 2, 3, 4, 5. So your element is on fifth position. Suppose your element is here 150. Okay, if you pass 150, so in this case your 150 is not in the list, so it will return element is not in the list. And you can see element is not in the list. So this is about the linear search. Okay, students. So next type of searching is binary search. Okay, as the name suggests, binary search. It means here you will break your list into two sublists. Okay, so this technique works on the shorted list. You have to keep in mind. So binary search techniques works on shorted list. Okay, first of all you have to sort the element, or you have to input the element in shorted order. Okay, so this is an important part. Okay, shorted list. Okay, so implementation of this technique is as done. So this the another name of this technique is divide and conquer technique. So first of all you will divide the list and you compare the element to the middle element. Okay, so similarly if your element is not present in the list, so then you will compare to left part, either left part or right part. Okay, and again you will divide your list. So I am calling this list binary search is a divide and conquer search. Okay, so what is the algorithm? So first of all you will compare your searching element to the middle element. Okay, if your element matches with the middle element, it will return the mid index. If your element is equal to the middle element, it means your element is searched and you will return the index. Okay, if your element is not equal to the middle element, either it will be the greater to the middle element or it will be lesser to the middle element. Okay, if your element is not equal to the middle element, so it will be the greater than middle element, or it will be less than middle element. If your element is greater than middle element, so in this case it means your element lie in the right part. Okay, right part sublist. Okay, if you apply the algorithm again for the right half, so you will again divide your list. Okay, and you will compare to the middle element again. If your element is greater than again middle element, then you will again divide your list. So this is technique is known as divide and conquer technique. If your element is smaller, it means your element lie in the left part. So we apply the algorithm for the left. Okay, let's take an example. I know it is very critical searching. Okay, it's a critical topic. That's why take an example. For example, you have the list of elements here. So first condition for binary search is your element must be in sorted order. So here you have the element in ascending order. Okay, how many elements we have? I have 1, 2, 3, 4, 5, 6, 7 elements. But index start from 0. The starting index is 0 and last index is 6. So this is your low. This is your, suppose this is your low and it is your high. This is your low index and this is your high index. So what you have to do, first of all you have to divide your list. First of all you have to find out the mid position. Let's take the mid position. How can you find out the mid position? To find out the mid position, 0 plus 6 divided by 2. If you 0 plus 6 divided by 2, now you will get 3. It means it is your middle element. In the mid index you have 35, so you will compare your element to the 35. For example, here your searching element is 65, for example. Okay, so now Your mid is 3. Now you will compare 65 to the middle element. So check your element is equal to the middle element. No. Then check your element is greater than middle element or lesser than middle element. So your 65 is greater than 35. It means your element will be found in the right part of the list, not in the left part. So ignore it and you have to search your element in the right part. So in this case, your low. Now this list will be ignored and you will get a new list. So here your low value will be mid plus 1. Here mid is 3 and 3 plus 1 will be 4. So this is your low index and this is your high index. Now again you have to find out the mid value. So in this case you will get 4 plus 6. This is 10 and 10 divided by 2 will be 5. So in this case your mid element will be of fifth index. So in the fifth index you have 65. Your searching element is 65. So 65 equal to 65. So in this case you will get your index. You will get the position of the element. Okay. What will happen if your searching element is 12? So again this is your low index and this is your high index. Your mid value will be 0 plus 6 divided by 2, then you will get 3 here. Mid value is 3. So now you have to you will compare 12 to 35. So 35 is equals to 12. No. And 12 is less than 35 or greater than 35. Obviously it is less than 35. So in this, it means your element will be lie in the left part of the list. Okay. So here your high will be mid minus 1. So mid value is 3 and mid minus 1 will be 2. So this is your new high. Okay. Now again find out the mid value. So 0 plus 2. 0 plus 2. 2 and 2 divided by 2. You will get the 1. Okay. So now compare your element 12 to 20. Your element is equal to 20. No. And 12 is less than 20. So it means your element lie in the left of the 20. Okay. So now your high value will be mid minus 1. The high value will be 0. So here your now 0 will be low and 0 will be high. And again you will get the mid value. Mid value will be 0 plus 0 divided by 2. That will be 0. Mid value is 0. Now 12 will be compared to 12. It means you have got your index, that is 0. Okay. So this is the technique to find out the element using binary search. Okay. Now go to the program. First of all, write down binary search. Okay. So you have to pass the two parameter, that is list, and you have to pass the searching element. Okay. Like linear search. So what you have to do, first of all, you have to take low. The low will start from 0. Okay. And what will be your high? Your high will be the length of the list. Okay. Length of your list. And what will be the length of the list? Okay. Number of elements, but your index starts from the index of the list start from 0 and go to the length of minus 1. That will be minus 1. What I am saying, how many elements in the list? In your list you have 7 elements, but high your index go to 6. Okay, so high value will be length of the index, length of the list minus 1. Okay, so initially the high will be here. Okay, this is your high. Number of elements are 7 and index, the high index will be 6. That's why I am reducing it to minus 1. Okay, now you have to check the value while low is less than equals to high. What does it mean? When I am comparing this value 12, so in this case low and high are equal. Okay, what will happen if your element is not present in the list? Suppose your element is 10. Okay, so 10 is equal to 12. No, 10 is less than 12. So in this case it will reduce the value of high to mid minus 1. What is the value of mid? That is 0, and 0 minus 1, that will be minus 1. Now new value of high will be minus 1 and low will be 0. So in this case, low never be less than high. That's why I am writing the condition here. The low must be less than equals to high. Okay, find out the mid value. Mid equals to low, sorry, low plus high. You have to use the floor division. Why? Because I do not want the value in integer. That's why I am using floor division. Okay. Now check condition. If your element is equal to the mid index. If your element is equal to the mid index, it means your searching is complete and you will return mid plus 1. Okay. If your element, if x is less than, if your element is less than the middle element, so in this case it will now new value of, now check, if your element is less than the middle element, for example you are searching here 12. Okay, so here first of all you will find the mid value will be 35. If your value is less than 35, so in this case your high will be mid minus 1. So new value of high will be, will be your new high, that will be mid minus 1. Okay, so here your high will be equals to mid minus 1. Okay. Else it means your element is greater than middle element. So in this case what will happen? Now you can see, if you are searching the element that is equals to 65, so in this case what will happen? If you are searching 65, so 65 is more than 35, so in this case your element lie in the right part of the list. So in this case the low will be mid plus 1. Mid value is 3. Now new low value will be 4. Okay, that's why I am taking low equal to mid plus 1. That will be low equals to mid plus 1. Okay, if your element is not present in the list, so in this case you will return minus 1, like linear search. Okay, so this is the technique, this is the function to find out the element using binary search. Okay, so first of all you will initialize low equals to 0 and high equals to length of the list minus 1. Basically this is the first initial index and this is the last index. Okay, so you will check the condition. Your program will go till the low is less than equals to high. First of all you will find out the mid position. If your element is equal to the middle element, it means your search is complete and you have found the element or the mid plus 1 position. If your element is less than the middle element, so in this case what you will do, you will decrease the value of higher index to, that will be mid minus 1. If your element is greater than middle element, so in this case your low will be moved to the right side, that will be mid plus 1. If your element is found, so it will return mid plus 1, it means that will be the positive value. If element is not return any value, it means it will return minus 1. It means your element is not present in the list. Okay, so this is the definition of your function. Okay, write down definition of function. So next is calling of function. Calling of function. So take any list like this, my list, and what is the condition? To use binary search, your element must be in sorted order. So write down here 85, 89, 100, 150, 170. Okay, and find out the position. To position equals to use binary search, and you have to pass the parameter my list and element. Which element do you want to search? I want to search 85. Okay, and check if position is equal to -1. It means your element is not present in the list. Write down print element is not present the list. Okay. Else it means your position is not -1. It means the element is present in the list. Write down the print statement print element is present at here POS as position. Okay. Now run your program. If you run your program, so you can see your element is found. Element is present at second position. So what is the position? 85, 1, 2. Element is found on the 85 position, second position. Okay. If you want to find the 170, search. Your element is on the sixth position. 1, 2, 3, 4, 5, 6. Okay. If you write down here 170, write down 180. Write down here, it means element is not present in the list. So this is about the binary search. So enough for this lesson. Thank you, students. Have a nice day. Be healthy, be safe. It is a very important part of the list. So you have to watch this video again and again to learn about linear search and binary search. Basically, binary search is most important. Okay. Thank you, students.